Welcome to part 2 of this video, in which we're using the method of joints to find the tensions in each of the members of a truss, of a 5-joint, 7-member truss, which I've got drawn here. So in part 1, we were off to a good start. We had found the tension in member AB. This is TAB. And we'd found the tension in member AC. So this is TAC. So the next joint we'll look at is joint B. And we know that here we'll have a tension TAB, which we've already found. So we'll use joint B to find TBC and TBD. And so let's do that. Okay, at joint B, we have tension TAB, tension TBC, and tension TBD. Okay. These are forces. Their magnitudes are unknown. We know their directions because we know the directions of the members. Okay, so, and again, we know that the angles here are 60, 60, even though I haven't drawn it very well, and 60. Okay, so let's look at the sum of the forces in the x direction. We have minus TAB, because it's pointing to the left, cosine of 60 degrees, plus TBC, cosine of 60 degrees, plus TBD, and this is equal to 0. So we know the value of TAB, but we don't know BC or BD, so we will have to look at the sum of forces in the y direction. And here we have minus TAB sine 60, minus TBC sine 60 degrees, is equal to 0. Okay, this is the component of TAB and TBC in the vertical direction. And this, let's see, this tells us then that TAB would be equal to, or I'm sorry, TBC, let's made a mess, TBC is equal to minus TAB, and we know that minus TAB is going to be 577.4 newtons. This is from a value that we've already computed. Okay, so that's what we get from f of y is equal to 0. If we now take TBC and plug it in here, we'll have then minus TAB, which is minus 577.4 newtons, times cosine 60, which is 1/2, plus 577.4 newtons, this is TBC, cosine of 60, which is 1/2, plus TBD equals 0. And when we solve this, we then get TBD is equal to minus 577.4 newtons. Okay, so we've got 2 more tensions that we've been able to compute from joint B. So let's write these down. Okay, we had TBD and TBC. TBD was minus 577.4 newtons. TBC ended up being 577.4 newtons. Okay, so again, we're making great progress here. The next thing we'll do is we'll look at joint C and do a free body diagram there. And we know TBC, we know TAC. So, whoops, we know that I'm also drawing the arrows backwards because I've got a cat that's in front of my screen. One should never allow cats to get near one's computer. Okay, so now we'll find TCD and TCE from a free body diagram of joint C. Okay, so joint C. This is actually, I guess, pin C. Pin C resides at joint C. Holds everything together at joint C. We have these tensions. We have TAC, TCE, TBC, and TCD. We also have a load, and the load is 1 kilonewton. And all of these angles here are 60 degrees. Okay, so by now you're probably beginning to see what the pattern is. We apply sum of forces in the F direction is 0, and this will give us minus TAC minus TBC cosine of 60 degrees plus TCD cosine of 60 degrees plus TCE is equal to 0. Okay, and if we look in the y direction, we have let's see, in the y direction we'll have TBC sine of 60 plus TCD sine of 60 minus 1 kilonewton is equal to 0. And we know what TBC is. We've already computed this. And so we can then solve this equation for TCD. I'm not going to go through any of the details here. We can solve it for TCD being 577.4 newtons. We can then take this expression for TCD, plug it in here. We already know TAC, TBC, and so we can get then that TCE is equal to 288.7 newtons. Okay, so we've got two more values that we can take back to our free body diagram and write down. We had TCE is 288.7 newtons, and TCD was 577.4 newtons. Okay, we're almost done, and hopefully you're beginning to see that there's some symmetry in these relationships, so we ought to be able to predict what the tension in member DE is just by looking over here, but we won't. We'll go through the whole thing in brutal detail. The thing to note, though, is that I have only one unknown left. We have found all of these guys that I've drawn arrows for so far. So now the only thing left to find is TDE. So I can look for TDE either at joint E or joint D. It doesn't really matter which one I choose. One might be a little easier than the other. Let's look at joint E. And, well, actually, let's look at joint D. So I go back to a scratch window, give myself some space. Okay, so the free body diagram of pin D, I have TBD going off, I know that. I have TCD, I know that. I have TDE, which I don't know. Okay, now I'm going to go straight to the summation of forces in the y direction is equal to 0. The reason I'm going to do that is if I do this, then TBD isn't going to show up in the sum of forces in the y direction, and it'll make life a little bit easier. So I have minus TCD times sine of 60 degrees minus TDE sine of 60 degrees equals 0. And I can solve this then for TDE, because I already know TCD. So I solve this for TDE is equal to minus 577.4 newtons. Okay, so I'll go back to my free body diagram and write this in. This is minus 577.4 newtons. Okay, so we're almost done. Just one last thing to point out. The terms, or the members where the tension is negative, are actually in compression. So, for example, this member here, joints D and E are pushing towards each other. Joints B and D are pushing towards each other, and joints A and B are pushing towards each other. The other members are in tension, that is, they're being pulled apart. So you can see that the internal members are being pulled, and the members on the edges here are being compressed. Okay, so that pretty much wraps up this video. I hope you found this example helpful.